Hello everyone, welcome back. Today we're going to answer a fundamental question that every astronomer slash astrophotographer sometimes asks themselves, especially when they're starting out, and it's why do we polar align our equatorial mounts to Polaris? And more importantly, why does it work? So let's dive into Stellarium and explore what's really happening in the sky. So let's start with the basics. As we know, the Earth rotates on its axis once every 24 hours. And from our perspective here, if you're outside at night, it looks like the entire sky is rotating around us in the opposite direction. So if you're here, yes, this is my house looking east, and the sky at night just starts going, above our heads, and it moves from east, and eventually all these stars that pop out in the east will eventually migrate over to the west at some point during the night. Now here's a key insight. So think about the Earth spinning like a top. It has an imaginary line running through it from the North Pole to the South Pole. So let's turn on the grid here to try to imagine this. So that line, that's what we call the Earth's rotation axis, right? So let's imagine a line going all the way from here, all the way down to the South Pole, and that's the Earth's rotation axis. Now, if we took this line, imaginary line, and extended it past our sphere, into space, into the stars, it would point to a specific spot in the sky, specifically a star, a group of stars. So we call that spot the North Celestial Pole. And we want to think of this as the bullseye that the Earth's North Pole is pointing at. So right here, this is the bullseye. Now let me show you something amazing. So I have Stellarium pointing north right now, and I'm going to speed up the rotation of the stars. Now look, notice how the stars don't move across the sky in a straight line, right? Instead, they're moving in circles around our central point here, right? And if you watch carefully, there's a star right here that's very close to the center and barely moves at all. That's the area where the North Celestial Pole is located. And conveniently for us in the Northern Hemisphere observers, there happens to be a relatively bright star very close to this point, and we know what star this is. This is Polaris. Now, Polaris isn't exactly at the perfect bullseye point. You can see that. It's actually about 0.7 degrees away from it. What that means is in over 24 hours, if you watch it carefully, it actually creates a small circle around our North Celestial Pole. But the circle is so small that for our purposes with our telescopes, it's close enough to call it stationary. Now, the further away you get from Polaris, like these stars over here on the right, these make huge circles as time passes, right? So these are the ones that rise in the east and they set in the west, traveling all the way across the sky. And that's why Polaris is special, right? So it appears nearly stationary for us while everything else wheels around it. And that's exactly what we need for our telescope mounts. So think about what happens when we're trying to take pictures or we're trying to look through our telescopes at night. The Earth is spinning and the object we're looking for, sometimes appears to drift across the sky. So if I am, for example, trying to look at, for one of my favorite galaxies is Bode's galaxies, right? Bode's galaxy. And if I'm here and I'm trying to look at it through my, my eyepiece, eventually, if this thing is going to just drift away from our eyepiece. And we constantly have to adjust, right? Either up or down, or side to side, just to keep what we're looking at in view, and that gets annoying really, really fast. However, if we polar align our mount, just like we just discussed, then our mount is going to be pointing at the same spot in space as the Earth's axis points to. And all we have to do is turn one knob on that mount, where if it's motorized, you let it track it, and it'll keep our target perfectly centered in our eyepiece throughout the night. When we polar align our mount, We physically tilt and rotate the mount until one of its axes is pointing directly at Polaris, or more precisely, at that spot in space that Earth's North Pole points to. And since Polaris is right next to that spot, we use it as our guide star to get everything lined up. Once we're aligned, here's where the magic happens. One axis of the mount is now tilted at the same exact angle as the Earth's axis. That means when we slowly rotate the telescope around that axis, we're basically canceling the Earth's spin. So the mount rotates at the same speed as the Earth, but in the opposite direction, which keeps our target or star or galaxy or whatever we're looking at perfectly still in the camera or showpiece. For long exposure for astrophotography, this is absolutely critical. Without accurate polar alignment, your stars will drift across your camera frame during the exposure, and they'll appear as streaks instead of points. So the better your polar alignment is, the longer you can expose without star trailing. Just a quick note, if you're in the southern hemisphere, so the same principles apply, but you'll be aligning to the south celestial pole. Unfortunately, there's no bright star equivalent to Polaris. The closest is what you see here on my screen, which is Polaris Australis, but it's only a magnitude 5.4 and making it much harder to see. I do know that there are some polar scopes that have special reticles designed for southern alignment, so you'll have to rely on that if you're in the southern hemisphere. So there you have it. We polar align to Polaris because it marks the point in the sky that appears to be stationary as the Earth rotates. By aligning our mount axis to point to this celestial pole, we can track objects across the sky with a simple rotation around a single axis. So polar alignment is one of those things that seem mysterious at first. It can be very frustrating, but practice makes perfect. The more you do it, the easier it becomes. I had a hard time with this when I started, but now I can do this in a matter of minutes. You can do it manually, but there's tools to help you as well. Some equatorial mounts have a polar scope that helps you find and align your mount manually. There's an app called PS Align Pro that helps you do this during the day, or if you do not have a way to see Polaris from your location. And if you're a ZWO ASIair user, there's a polar align feature that helps you there as well. Once you understand the geometry of the Earth's rotation and the celestial sphere, it makes perfect sense. If you found this helpful, please give it a thumbs up and subscribe for more astronomy content. And let me know in the comments if this video has helped you. If you have any questions, I will try to answer them as best as I can. Thanks for watching, and clear skies.